Okay, and for the last demo, it's going to be 8 and 9. And for this one, the first problem is water quality and risks of gasoline spills may be affected by the prevalence of road arteries in each watershed. Using the road arteries feature class, determine the number of road miles in each watershed. Which 3 watersheds have the highest mileage, and capture a map showing the mileage for each watershed. So again, with this one, we're going to have a GIS layer for the arteries, which are the major roads, and then the watersheds, and we're going to do an intersect between the 2 of them. Okay, for this, we'll go ahead and add a new map, and for this one, EX8. Transportation, we only want the arteries. And then we need the watersheds layer, probably environmental watersheds. And so the destination, well, where we want all the information to show up is the number of miles of arteries, of roads per each watershed. So if we look at the attributes for the watersheds right now, we want new attributes added onto this that will be the number of road miles per each of these watersheds. There's a couple different ways to run this. One way is that if we run it where the information from the watershed name is appended onto each one of these roads, that would be one way to do it. If there'd be a new attribute added on to this attribute table. Right now CDB is the last column. We'd want a new column added on here. That's the for the road arteries, which watershed it falls in, and that would be another way to be able to run this. Okay, so if we perform a intersect on the 2 of these, let's just see. Using the artery feature class, determine the number of road miles in each watershed. Which 3 watersheds have the highest mileage? Okay, so the way I would set this up is I would, of course, do a intersect, where one of the inputs here is the arteries, the other the watersheds. Arteries intersect, and I'm just going to put underscore WS for watersheds. We want all the attributes to be included. And the output type is going to be the lines in this case. So if we turned off both of these layers, we only get those roads that fall within the watersheds. All those extra roads have been trimmed off now, as you can see. And then the other difference here is that if we open the attribute table of this resulting layer, we should get attributes about the names of the watersheds. So here's the watershed number, and then we need the DCM name, the watershed name, which watershed each of these fall within. Now there's also a new shape length that was added onto this based on after the intersect was made. And you see how this shape length has been truncated and it's a bigger number. It's going to be this shape underscore length is the one we want to use. So we need to also then tell how many miles instead of this is in feet. So we want to, like we've done before, go to the add. Then we need to add a field here for road length. And then I'm going to put miles and then make sure the data type, switch that to integer. Pardon me, from integer we want to put it to float so it has decimal places. Hit save. And then close this out. Populate that new field. Right click on it. And we're going to take the shape length, the one that's written out in full, this is important, divided by our 5280. Okay, so there's our number of miles per each length. Now, the key here now is to the DCM name, that's the name of the watershed, notice there's lots of repeats in here. And so what she's asking us to do is this essentially becomes like a many-to-one join. We want to get a table, a standalone table that has one record, and it's the sum of all the lengths of the roads within each of these watersheds. So this is kind of a complicated one. The way that I like to do this is to run a summary on the DCM name. And remember, there's a summarize. This is going to make a new standalone table where the input from this is the artery roads intersect with the watersheds. The output table will be the artery intersect, and then it's statistics of all those roads. So I'm just going to put summary stats. The field that we want is the length of the roads in miles. And then, what is she asking for? Let's take a look at her question again. She wants which 3 watersheds had the highest mileage, and then make a map showing the mileage for each watershed. Okay, so this is going to make a standalone table that we're going to join back to the watersheds to show the total number of miles, which we're going to take as the sum. Case view. Yes, let's hit run on this. So this should make a new standalone table. There it is. And what we should expect is there's only one record for Brushy Creek, one for Lake Creek, and so forth. Let's just look and see if this table, if we open this, is the type that we want. And so there's only one record for Brushy Creek. There were 54 road segments in that one, and when you sum up all the miles, that one comes out to be 72. We can already answer her question by sorting these. So Onion Creek, Walnut Creek Watershed, and Brushy Creek come up as the top 3. We can do a quick check on our work. So Onion Creek, Walnut Creek, and Brush Creek have the highest number, but to make the map, we need to then join the table to the watershed to be able to map it. So we're going to take the standalone table based on the DMC name and join it back to the watersheds. So right now, when we look at the watersheds layer, it has a lot of attributes, but it does not have one for the sum of the number of road miles, and that's what we need to add on here in order to map that. So right-click on this. Remember, joins and relates. But this time we're not doing a spatial join, we're doing a table join. So we just say add a join. Input table in this one is the watersheds. The input field is that name, which is the DCM name. The join field is the arteries intersect summary statistics. I already chose that one. It also recognized that there was a similar column, so I did that one. It doesn't matter if we keep all records or not. There should be a one-to-one relationship between these, and we'll click OK. So if this works, when we open up the attribute table now for the watersheds, there should be a number of miles added on here. There's that sum, road length, and miles. There it is. We can then use this in the symbology, change the symbology to graduated colors, pick that sum of miles, and then we end up with this map. So if we turn off the arteries one, this is what that map looks like. Some of these big watersheds, of course, end up with lots of miles of arteries. Some of these little tiny watersheds in here end up with less, corresponding to just a smaller footprint. But let's see if this looks similar to the map that she produced, and it's almost identical. Where the upper end of that lower one is 5.4, upper end of everything is 97, and so that's how you get the right answer there. So basically, in summary, this one was a intersect between the arteries and the watersheds. We then had to do a summary statistics on that resultant arteries layer, which had a column for the watershed name. We used the sum feature, which produced a standalone table, and then we joined that table back to the watersheds in order to map it. All right, that is number 8. Number 9, moving on. Perhaps the total of the street miles is a better measure than the arteries. Repeat watershed analysis using the street feature class and compare the results. List the 3 watersheds with the highest mileage and capture a map showing all of the watersheds. All right, so good news. we could do that. It felt a little redundant, so I thought I would just double check the question, and it turns out we only have to go up to number 8. You would do the exact same thing, but on that one, except for instead of using arteries for this one, you would go back in here, and then you would add all of the streets rather than just the arteries. I chose for you not to do that problem because it really isn't a lot more value in terms of what you get experience with. You could do that pretty easily. So anyhow, stopping with question number 8, then we are done with this demo. All right, good luck with everything, and reach out if you have any questions about any of these problems.